I welcome you all in this session of Basic Mechanical Engineering. I am Suresh Chaudhary, Assistant Professor, SKIT, Department of Mechanical Engineering. In this series of the video lectures, we have already completed the internal combustion engines, the refrigeration and air conditioning part. Now we will study about the boilers. So first of all, let me define a boiler, and then we will discuss the important terms used in the boiler and the classification of the boilers. In this chapter, we will understand what is the meaning of a boiler, what are the important terms which are used in the boilers, and simple classification of the boilers. Now, what is a boiler? The boiler is also known as a steam generator. Please note, the boiler is also known as a steam generator, and it is a device or equipment which is used for production of steam. Boiler or steam generator is a device which is used for production of the steam. How the steam is produced actually inside the boiler? Inside the boiler, some sort of the fuel is used. Inside the boiler, some sort of the fuel is used, and this fuel may be solid, liquid, or gaseous fuel. The heat released from the combustion of fuel, is then utilized to convert the water into the steam at a desired level of pressure and temperature. Please note, the boiler utilizes some form of the fuel. The fuel may be solid, gaseous, or liquid fuel. Then the heat released from the combustion of this fuel is utilized to convert the water from liquid to steam at a desired level of pressure and temperature. Now, this steam has multiple applications. This steam can be used for industrial or commercial purposes. It can be used for heating of the households, and the steam is also used for production of electricity in the power plants. Please note, there are multiple applications of this steam which is produced by the boiler. One of the most important application of this steam is in the thermal power plants, where this steam is expanded into a turbine to produce the electricity or electrical energy or electrical power. So to conclude, boiler is an equipment which is used for production of steam, means it converts water into the steam at a desired level of pressure and temperature. Now, it is a very complicated device. It is not a simple chamber. Rather, there are some important terms which are used in the boiler. Let's study important terms which are used in the boiler. The first term is the boiler shell. I'm talking about the construction of the boiler. In this session now, some important terms used in the boiler, meaning some of the important components of the boiler, or you can say the basic configuration of the boiler. What are the important terms which are used in the boiler are: first is boiler shell. Boiler shell is a closed chamber or a closed vessel that contains water and steam at a working pressure. Steam is produced inside the boiler shell. Boiler shell is usually made up of steel plates, and these steel plates are bent in the cylindrical form, either using cylindrical form and riveted or welded together. Please note, a boiler shell is a closed chamber or a vessel. It contains all other parts of the boiler. At the same time, it also contains water and steam. For example, your pressure cooker is a kind of boiler where water is converted into the steam, and now the outer this shell of the boiler is the body of the pressure cooker, is the shell of the boiler. So shell of the boiler is the most important part of the boiler, which holds all other important parts of the boiler together, at the same time contains water and steam. So this is the boiler shell, the outer layer of the boiler or outer membrane of the boiler, which holds all other parts of the boiler together, at the same time contains water and steam, is known as the boiler shell. The next important part of the boiler or term in the boiler is the furnace. The next important part is the furnace. Furnace is basically the place where the combustion of the fuel takes place. Please note, furnace is the place where the combustion of the fuel takes place. From the combustion of the fuel, the hot flue gases are generated, and these hot flue gases are then utilized to convert the water into the steam. Please listen to me very carefully. Furnace is the place where the coal or some other fuel is fired. Through the firing of the coal or other fuel, hot flue gases are generated, and these hot flue gases are now utilized to convert the water into steam. Therefore, furnace is also known as firebox because fuel is burnt over here. Another important component or term which is used in the boiler is the grate. The grate is that platform inside the furnace wherein the fuel is burnt or upon which the fuel is burnt. Please note, grate is that platform over which fuel is burnt. So grate may be a perforated platform through which air is also supplied that assists in the combustion of the fuel. So grate is the platform. The grate is a platform inside the furnace upon which the fuel is burnt. Please note down this terminology very carefully. Now, there are certain other components of the boiler or terms which are used in the boiler. They are mountings and accessories. Boiler mountings and boiler accessories. Boiler mountings refer to all those fittings or components which are mounted on the boiler and they ensure the safe operation of the boiler. Please note the meaning of word mounting. Mountings are the essential parts of the boiler. Without mountings, the boiler cannot function. The mountings, I am again repeating, mountings are the essential components of the boiler. Without mountings, boiler cannot function. Mountings assist in the safe operation of the boiler. Please, they are the essential components of the boiler. They ensure safe operation of the boiler. One of the example of the mountings is the pressure gauge. Another example is a safety valve. For example, the safety valve of a pressure cooker. The safety valve of a pressure cooker. When the steam pressure goes beyond the working range, that safety valve opens and relieves some of the steam and thus maintains the pressure inside the boiler or inside the pressure cooker. So mountings, again I am repeating, mountings are the essential parts of the boiler. Without mountings, the boiler cannot function, and mountings basically ensure the proper safety during the functionality of the boiler. The examples are pressure gauge, safety valve, etc. We will understand mountings altogether separately. Now accessories, since the name itself implies, accessories are not the essential parts of the boiler. Accessories are not the essential parts of the boiler. Without accessories, a boiler can function. Without accessories, a boiler can function, but accessories assist in enhancing or increasing the performance or efficiency of the boiler. Please note the word performance or efficiency of the boiler. Without accessories, the boiler can function, but with accessories, the efficiency of the boiler operation is increased. So accessories basically assist in enhancing the performance or efficiency of the boiler. Please note this difference. They are the essential parts of the boiler. They are non-essential parts of the boiler. They ensure safety during the operation. They ensure higher efficiency during the boiler operations. Now, these were the important terms which were used boilers. Please note these important terms. One was the boiler shell that contains all other parts of the boiler together and also contains the water and the steam at a desired level of pressure and temperature. Next was furnace. Furnace was a firebox where the fuel is burnt. The grate was the platform, or grate is the platform inside the furnace upon which the fuel is fired or combustion of the fuel takes place. Another two important terms were mountings and accessories, which we have seen. Now let's classify the boilers. There are multiple criteria to classify the boilers. You may find 10 or 15 criteria. Different books use different criteria to classify the boilers. We will understand some of the important criteria on which the boilers have been classified. So the boilers are mainly classified according to the following criteria. The first criteria for classification of the boiler is the relative position of the hot gases and water. Please note, when fuel is fired inside the furnace, the hot flue gases are generated, and these hot flue gases exchange heat with the water, means they transfer heat to the water and the water is converted into the steam. Now, the classification of the boiler, the first important criteria for the classification is the relative position of the hot gases and water. Please note, according to this criteria, relative position of hot gas and water, the boilers can be classified into the two categories. One is fire tube boiler and another one is water tube boiler. On the basis of this criteria, that is relative position of hot gases and water, the boilers can be classified into the two categories. One is fire tube boiler and another one is water tube boiler. Please note what is the meaning of this fire tube and water tube boiler. In a fire tube boiler, please note, in a fire tube boiler, the hot flue gases which are generated through the combustion of fuel, which is the product of combustion of the fuel. Please note, The hot flue gases, which are the product of combustion of the fuel, means the hot flue gases are generated inside the furnace when the combustion of the fuel takes place. Now these hot flue gases pass through the tubes that are surrounded by the water. In a fire tube boiler, please note the two points. One is shell, another one is the tubes. In a fire tube boiler, the hot flue gases which are generated through the combustion of the fuel pass through the tubes. They flow through the tubes, and these tubes are surrounded by the water. The tubes are always surrounded by the water. There are multiple tubes and water is surrounding these tubes. And through these tubes, the hot flue gases are flowing. Through these tubes, the hot flue gases are flowing. And while water is surrounding these tubes outside the tubes. Such an arrangement is known as fire tube boiler. So in a fire tube boiler, the hot flue gases, which is the product of combustion of the fuel, flow through the tubes, and water is there outside the tubes inside the shell. The heat from the hot flue gases is transferred to the water, which is converted into steam. The examples of the fire tube boiler are Cochrane boiler, Lancashire boiler, locomotive boiler, Scotch marine boiler, etc. These are the examples of the fire tube boiler. I think you have understood the meaning of fire tube boiler. I will clear it with the help of a diagram. Please note in the next paper. Please observe. Now another important observe over here. First let's see the fire tube. What is the meaning of fire tube boiler? This is the grate where the combustion of the fuel is taking place. Air is supplied. From the combustion of the fuel, hot flue gases are generated. Now these are the tubes. These are the tubes through which these hot flue gases are flowing. These are the tubes through which the hot flue gases are flowing, and then hot flue gases leave the boiler through this chimney. Hot flue gases are leaving to atmosphere through the chimney. So these are the tubes through which hot flue gases are flowing, and outside these tubes is the water inside the shell. Outside these tubes means these tubes are surrounded by the water. These tubes are surrounded by the water, and heat is transferred from hot flue gases to the water, and water is converted into the steam which is taken out from this passes. I think you have understood. Please again note, this is the grate where the combustion of the fuel is taking place inside the furnace. The hot flue gases generated from the combustion are allowed to flow through these tubes. Allowed to flow through these tubes. And the water is there outside the tubes. Water is there outside the tubes. The heat is transferred from the hot flue gases to the water. The water is converted into steam and it is taken out from here. While the hot flue gases, after transferring heat to the water, are allowed to discharge into the atmosphere through the chimney. So this is the fire tube boiler wherein hot flue gases flow through the tubes. Another category is the water tube boiler. In water tube boiler, the tubes contain water. Inside the tube, there is water, and hot flue gases produced by the combustion of the fuel flow outside those tubes. Please note, now in the water tube boiler, the name itself implies that the tube will contain the water. The water will be flowing through the tubes, while the hot flue gases will flow outside the tubes. As a result of temperature difference between the hot flue gases and water, the heat will be transferred to the water, and water will convert into the steam. The examples of water tube boiler are Babcock and Wilcox boiler, Lamont boiler, Stirling boiler, Benson boiler, Wilcox boiler, etc. Now see the configuration of water tube boiler. In a water tube boiler, these are the tubes. These are the tubes. This is the water drum. You can say this is the boiler drum. The water is supplied through these tubes. The water is supplied over here. This is the inlet. This is the grate where the combustion of the fuel is taking place. Here the combustion of the fuel takes place. From combustion of the fuel, hot flue gases are generated, and these hot flue gases are allowed to flow like that in upward direction. Because they are hot, they will flow in upward direction. And now these are the tubes through which the water is flowing. These are the tubes through which water is flowing. The hot flue gases are passing around those tubes. The hot flue gases are flowing around those tubes and causes the conversion of water into the steam, and it is again collected inside the boiler drum, and the steam which has been produced is taken out. This configuration I will make you understand how this water and steam are separated and the steam is taken out later on. Please observe the basic terminology. That is, in water tube boiler, the water flows through the tubes and the hot flue gases flow outside the tubes. In water tube boiler, the water flows through the tubes and the hot flue gases flow outside those tubes, and heat is transferred from hot flue gases to the water, and water is converted into the steam, which is again collected inside the boiler drum and taken out as per the use, while the hot flue gases, after supplying heat to the water, leave through the chimney to the atmosphere. So the name implies, in fire tube boiler, the flue gases flow through the tubes while water is there outside the tubes. But in water tube boiler, water flows through the tubes and hot flue gases flow outside those tubes. I think terminology is very much clear to you. I have written down the theory, fire tube boiler, water tube boiler, along with their examples. Now, this was the first criteria of classifying the boilers. Now, the second criteria for classifying the boilers is the method of firing. The second criteria is the method of firing. According to this criteria, the boilers can be classified into two categories. One is internally fired boiler and another one is externally fired boiler. Please note, in an internally fired boiler, the furnace is provided within the boiler shell itself. The furnace internally fired, the word is internally fired. It means that the furnace is provided within the boiler shell itself. The furnace is provided within the boiler shell itself. The examples of internally fired boilers are locomotive boiler, Lancashire boiler, Cornish boiler and Cochrane boiler, etc. And in externally fired boiler, the furnace is provided outside the boiler shell. The furnace is provided outside the boiler shell, and this furnace is simple in construction. The examples are Babcock and Wilcox boiler. Please note the diagrammatic representation. This is an internally fired boiler. This is an internally fired boiler. This is an internally fired boiler. And this is an externally fired boiler. Please note, this is externally fired. How? In internally fired boiler, the furnace has been provided within the boiler shell itself. The furnace is provided within the boiler shell itself. The flue gases which are generated from the combustion are supplied to the water which is flowing through these tubes. But in externally fired boiler, the boiler shell is there. The furnace is outside the boiler shell. The furnace is outside the boiler shell. The fuel is fired inside the furnace, and then this hot flue gases are allowed to enter the shell of the boiler. Please note, in externally fired boiler, the furnace is outside the boiler shell. Furnace is located outside the boiler shell. The fuel is fired inside the furnace. Now the hot flue gases which are generated from the combustion of fuel are allowed to enter the boiler shell, which in turn heat up the water and convert it into the steam. Now, one of the advantages of externally fired boiler is that its furnace is simple in construction and it can be changed according to the capacity. The size of the furnace can be changed according to the capacity, according to the amount of steam you want to produce. So the furnace is simple in construction in case of externally fired boiler, which is an advantage over an internally fired boiler. Here the design of the furnace is a little bit complicated. Here the design of the furnace is a little bit easier and it can easily be changed according to the use. Now the third important criteria for classifying the boilers is the method of circulation. Please note, what is the meaning of this method of circulation? According to the method of circulation, the boilers can be classified as natural circulation boilers and forced circulation boilers. Natural circulation boilers and forced circulation boilers. In natural circulation boiler, circulation of water takes place by natural convection currents or by gravity. Please note, in a natural circulation boiler, the water is circulated inside the boiler or outside the boiler either as a result of natural convection currents or by gravity. What is the meaning of natural convection currents? It is that the cold water flows itself downward and hot water, once get heated up, flows upward. This is the natural convection. Meaning of the natural convection is that the flow of the water takes place as a result of natural convection currents, that is as a result of difference in the density of the working fluid itself. The hot water flows up, and cold water flows down. This is the meaning of the natural circulation. So in natural circulation boilers, there is no use of the pump for circulation of water inside or outside the boiler. Please note, in natural circulation boilers, the circulation of the water inside the boiler takes place either due to the natural convection currents, that is due to the buoyancy, due to the density difference of the water, or as a result of gravity. The examples of natural circulation boiler are Cochrane boiler, Lancashire boiler, locomotive boiler, Cornish, and etc. Now let's see Forced convection boiler. What is the meaning of forced circulation boiler? Sorry. The forced circulation boiler, a pump is employed for effective circulation of water. What is the meaning of forced circulation? In forced circulation boiler, a pump is employed for effective circulation of water inside the boiler. And in natural circulation boiler, no pump is used. Rather, naturally itself, the circulation of water takes place inside the boiler as a result of density differences or as a result of gravity. So in forced circulation boiler, pump is used for circulation of water inside the boiler. But in natural circulation boiler, no pump is used. No pump is used for circulation of water. The examples of forced circulation boiler are Lamont boiler, Loeffler boiler, Benson boiler and Velox boiler. I think it is clear to you all. Now the fourth important criteria for classifying the boilers is according to the axis of the boiler cell. According to the axis of the boiler shell. Then according to this category, there are two types of boilers: horizontal axis boiler and vertical axis boiler. In horizontal axis boiler, the axis of the boiler is horizontal. The axis of the boiler is horizontal. But in vertical axis boiler, the axis of the boiler is vertical. Please note, in horizontal axis boiler, the boiler configuration is horizontal in nature. In vertical axis boiler, the axis of the boiler is vertical. The examples of horizontal axis boiler are Lancashire boiler, Cornish boiler, Stirling boiler, Babcock and Wilcox boiler. While in vertical axis boiler, the examples are simple vertical boiler, Cochrane boiler, etc. Okay, now the fifth important criteria for classifying the boilers is according to the number of tubes. It is very easy to classify single tube boiler and multi-tubular boiler. In a single tube boiler, there is only one tube inside the shell. There is only one tube inside the shell through which water may flow or through which the hot flue gases may flow. So there is only one tube inside the shell. The examples are Cornish boiler or simple vertical boiler. And in a multi-tubular boiler, there are a number of tubes for carrying water or flue gases. There are many water tubes or fire tubes. The examples of multi-tube boiler are locomotive boiler, Lancashire boiler, Cochrane boiler, Babcock and Wilcox boiler. I am writing the examples of each and every category. Please try to remember all those examples according to their category. So this is the fifth important criteria for classification of the boiler, that is single tube boiler or multi-tubular boiler. In a single tube boiler, there is only a single tube that either carries water or hot flue gases. In multi-tubular boiler, there are a number of tubes. Multiple tubes are there, and through these tubes either water may flow or flue gases may flow. Now the sixth important criteria for classifying the boilers is according to the use. Now there are easy criteria according to the use. According to the use, there are two types of boilers. One is stationary boilers and mobile boiler, and another one is mobile boiler. In a stationary boiler, the boiler cannot move from one place to another place. The boiler is stationary at its place and it cannot move from one place to another place. The examples of such boilers are those which are used in the power plant and industries. Stationary boilers are basically used in power plants and industries as they cannot move from one place to another place. The examples of stationary boilers are Lancashire boiler, Cornish boiler, Cochrane boiler, Babcock and Wilcox boiler, etc. While mobile boilers are those which can move from one place to another place. The word mobile itself indicates movement. That is, those boilers which can move from one place to another place are known as mobile boilers. Locomotive boiler and marine boilers are the examples of the mobile boilers. Now the seventh important criteria for classification of the boilers is the criteria of according to the steam pressure. At what pressure the steam is generated, that is very important criteria to classify the boilers. There are 5 categories under this important category. One is low pressure boiler, the boilers in which the steam is generated below a pressure of 20 bar. When the boiler operates at a pressure less than 20 bar, the boiler is known as low pressure boiler. Means the generation of the steam takes place at a pressure lower than 20 bar and it is known as low pressure boiler. In a medium pressure boiler, the generation of steam takes place within a range of pressure from 20 to 80 bar. When the boiler works within this range, then it is known as medium pressure boiler. High pressure boiler is a boiler that operates from 80 bar to 160 bar. That is, the production of steam takes place at a pressure ranging from 80 to 160 bar. Then it is known as a high pressure boiler. The another important boiler is subcritical boiler. Subcritical boiler is a boiler in which the pressure of steam is more than 160 bar, but it is below 220 bar. Below 220 bar, 221 bar is the critical pressure. So the boiler which operates within this range, means the production of steam takes place within this pressure range, is known as subcritical boiler. So subcritical boiler is a boiler in which the production of steam takes place at a pressure from 160 to 220 bar. And last category is the supercritical boiler. Supercritical boiler is a boiler that operates beyond 221 bars. Supercritical boilers are those wherein the production of steam takes place at a pressure higher than the critical pressure. This 221 bar is the critical pressure for water. So supercritical boilers are those boilers which operates above the critical pressure. Critical pressure. 221 bar is the critical pressure for water. So supercritical boilers basically generate steam at a pressure more than the critical pressure, that is beyond 221 bar. Subcritical boilers operate below the critical pressure. Subcritical boilers operate, you can take 221, no problem. Subcritical boilers operate below critical pressures. Supercritical boilers operate beyond or above the critical pressure, that is above 221 bar. So this is an important criteria for classifying the boilers, that is according to the pressure of the steam generated inside the boiler. The another or the last criteria for classifying for this lecture particularly is according to the capacity of the boiler. Low capacity boiler, medium capacity boiler and high capacity boiler. Low capacity boilers are those in which per hour 20,000 kg of steam is generated. This is the amount of steam generated. So in low capacity boilers, in 1 hour 20,000 kg, less than 20,000 kg steam is generated, then they are known as low capacity boilers. Medium capacity boilers are those in which per hour 20,000 to 75,000 kg steam is generated. This is the production of steam in 1 hour. In medium capacity boilers, per hour steam production is between 20,000 and 75,000 kg. In high capacity boilers, the high capacity boilers are those in which more than 75,000 kg steam is produced in 1 hour. In high capacity boilers, more than 75,000 kg steam is generated per hour. So this is the last criteria for classifying the boilers. There are 2 or 3 other important criteria which you can see yourself. Different books have used different criteria to classify the boilers. These were the criteria which were common to most of the books. That's why I have used these 8 criteria to classify the boilers. I think it is very much clear to you all the classification of the boilers, the meaning of the boilers, and the important terms which are used in the boilers. In the next lecture, we will study one of the boiler in detail and mountings and accessories in detail. Thank you.